The air you are breathing is part of an unimaginably complex fluid, a chaotic ocean swirling around a spinning planet. For decades, to predict its next move, we've relied on brute force. We use supercomputers the size of tennis courts to solve monstrously complex fluid dynamics equations for the entire globe. This is called numerical weather prediction, and it treats the atmosphere like a giant physics problem. But there's a fundamental limit, famously known as the butterfly effect. A tiny, immeasurable change in one place can cascade into a massive, unpredictable storm a week later. The system is just too sensitive. But what if you didn't need to solve the equations at all? What if, instead, you could just learn the weather? An artificial neural network doesn't begin with the laws of physics. It begins with data, decades of it. Every recorded temperature, pressure, wind speed, and humidity reading from the past 40 years. The AI looks at a snapshot of the planet's weather and is simply asked to predict the weather a few hours later. It does this billions of times, adjusting its internal connections, learning the intricate patterns of atmospheric flow. It's less like calculating the arc of a thrown ball and more like developing the intuition to simply catch it. A model from Google DeepMind called GraphCast embodies this approach. It doesn't see the Earth as a continuous fluid. It sees it as a graph. Over 1 million points covering the planet's surface and atmosphere are connected to their neighbors. The AI takes the current state of all these points, the wind, temperature, and so on, and processes this information through its network. It learns which connections matter most, how a change in pressure in the Pacific affects the wind over Europe. It's essentially learning the hidden language of the atmosphere directly from its behavior, not from a physics textbook. And the results are staggering. The world's best physics-based model, run by the European Center for Medium-Range Weather Forecasts, takes hours on a massive supercomputer to generate a 10-day forecast. GraphCast can produce a more accurate forecast in less than a minute on a single specialized Google processing unit. In a direct comparison, GraphCast was more accurate than the traditional gold standard model on over 90% of weather variables. This isn't a small step, it's a leap. The sheer speed means we can run hundreds of slightly different forecasts, called ensembles, giving us a much better handle on the probability of extreme events. This newfound speed and accuracy have profound implications. It's not just about knowing if you need an umbrella next Tuesday. These models are exceptionally good at spotting the precursors to extreme high-impact weather. They can identify the conditions that lead to dangerous atmospheric rivers, vast corridors of moisture in the sky, with greater lead time. They can more accurately predict the track and intensity of tropical cyclones, giving communities crucial extra days to prepare. This shift from hours of calculation to minutes of inference is a shift that can directly save lives. The potential reaches even further, beyond weather and into climate. Simulating the Earth's climate over decades is one of the most computationally expensive tasks in science. AI models, being thousands of times faster, could allow scientists to run countless simulations of our planet's future under different carbon emission scenarios. They could model complex feedback loops, like the effect of melting Arctic ice on ocean currents, with a speed that was previously unimaginable. It's a new tool, not just for predicting the rain, but for understanding the long-term trajectory of our entire planetary system. Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.